My Home VM Solution by Premade MicroOS. Introduction. I have a machine that has AMD Ryzen 9 3900X 12-core processor, and I want to enjoy container and Kubernetes. So I made several virtual machines on my physical machine. Yes, I know it's easy to use the cloud, but I want to use MicroOS, and I already have a physical machine. I have to spend money to use the cloud even if it is not expensive. At first, I use premade MicroOS or Cubic and manually configuration. I stop the virtual machines when I shut down the physical machine, and I start virtual machines when I want to use them after powering on the physical machine. I think I want to try to scale up the Kubernetes worker node, and sometimes I need a test environment. There is a way to create a worker node and virtual machine for the test environment and shut down it. But if I don't need them for a long time, I forget them and start them when I need. Sometimes they don't run, or after an update they don't run. Something breaks them. If I use them daily, it doesn't happen, but I'm lazy and I have to do something. So I thought if I set up declarative KVM, I can use virtual machines more easily. Declarative KVM. Machine setup includes how to set up and what to set up. I repeated how to set up each virtual machine. So I wrote how to set up parts to script, and I wrote what to set up to YAML. After that, if I wrote YAML and run the script, the expected virtual machines are created and run. I decided to keep simple each part, though this solution to success. There are two main areas where virtual machines need to be configured. One is virtual hardware parts like volume and network. Another is software parts. I use Combustion to set up virtual hardware parts, and I use Ansible and SaltStack to set up software parts. After being used, destroy script destroys these virtual machines. I briefly describe this solution. YAML. YAML has also two categories. One is hardware. This YAML file corresponds to one virtual machine, such as hostname and IP address are written in this YAML. Another is main and software. This YAML has what machine is run and what software is run. Now, this is only an automation script. This solution doesn't check if it has already started. I would like to implement this function. MicroOS and Combustion. MicroOS is immutable and tuned for the container. Combustion is a module to run a script at first startup. I use Combustion to set up hardware parts and base settings like hostname. The setup-based strategy is the template file. Combustion can read file system with the label Combustion and run script named script. I made template settings files, and script inject configs from YAML to the template setting files. On creation, my solution gathers these setting files and generates an ISO image labeled Combustion. If this solution attaches the ISO image when installation premade MicroOS to KVM, Combustion runs the script on startup, and Combustion script puts its destination. Combustion can do everything. Combustion can provision MicroOS. But I use Combustion only hardware parts and base settings, because I want to have several virtual machines which have each purpose. So I use infrastructure management tools for software parts. Combustion is the only script. If I implement several cases in it, it became more complicated. Script has many if statements. On the other hand, infrastructure management tools can use simple paths. Ansible and Salt Stack. I use these infrastructure management tools to set up software paths. I have a policy. I use Ansible for base settings, and I use Salt Stack for advanced settings like Kubernetes. I use openSUSE as the host. Virtual machines are MicroOS, so I can't have the same version of Salt between the host and virtual machines. This is why I use Ansible to base settings. Ansible doesn't use an agent. But I don't have a reason to use Salt Stack. If there is a reason I am using this, it is because I want to use it. I sometimes use virtual machines for simple services like Git. Usually, I run a container when I start services. I use Ansible for this setup. I wrote playbooks and I wrote YAML. If YAML has a role name for Ansible, my script writes section and IP address to the inventory file. Then kick the playbook. After that, Ansible sets up everything very well. Ansible has an implement role which is setting up Salt Stack. When setting up the Salt Stack master, Ansible gets an IP address from the master and writes it to the config for the Salt Stack minion. Grain config is also put. And after setting up the Salt Stack minion, Ansible lets Salt Stack master accept the minion's key. So I can use Salt Stack automatically. After the Salt Stack was set up, Ansible deploys states to Salt Stack master and kick these. Grain is used to identify the target machine. K3s. K3s is a lightweight Kubernetes. I use Cubic and Kubernetes for Kubernetes, but now Cubic is out of date. So I am replacing Cubic with K3s. I can create Kubernetes only to run the K3s script. My job is to write states the rest of the way. That would probably be easy. When I use Cubic, I run such as Prometheus, DocWiki, and Hover. If I can pull enough container images to run these, all I have to do is also write YAML. About my workflow, I put these scripts and YAML to the Git server which is run by this script. If I continue to develop this solution, or modify YAML or create a virtual machine to test, I pull this solution and do it. If either developed script works very well, I push it to the Git and clear pulled directory. This way is the same as product development. This is an outline of my home VM solution. From here, I explain solved problems and subjects I would like to try. These are solved problems. MicroOS uses Wix for network settings, so I write the script to set up a network. But someday, I replace the newer premade MicroOS, network doesn't work. I fall back premade MicroOS and start investigating in the newer image. I found a network module are replaced with Wix with Network Manager. I wrote connection settings and dispatcher. Somehow, it doesn't work after reboot. As a result, I write dispatcher which activates the connections. I think this is a bug, so I will file. Speaking of bugs, I have trouble with combustion. The combustion script setting to activate the network was broken. So I filed it and they fixed it. Thank you for their work. VM parallel creating. Usually, I start up several virtual machines because it includes some nodes for Kubernetes. They are created in order, and I should wait until all processes are finished. So I use the background processes for the bat install command and write the wait word after the command. This way reduces wait time. Now to create 4 virtual machines and set up the salt stack takes around 6 minutes. But I have 2 trouble. One is to write an Ansible inventory file. If some process writes it at the same time, the file is broken. So I use frac. It is a file log command. This premade inventory files are broken. The other one is the disk pool on KVM. After I put this solution, the second virtual machine creation echoes an error that the disk pool can't create. Maybe I can fix this that I create a disk pool after pulling from Git. First confirmation when SSH login. The first SSH login has 2 problems. One is after boot, I should wait until to get connected. Now I write retry and solve this, but this is not smart. Maybe the good way is adding a systemd unit that tells the host finished SSHD start to MicroOS by conversion. The other one is the first login asks me that is this server correct. I use SSH keyscan to solve this problem. The script automatically adds fingerprint to known hosts, but this way is not secure. I hope more secure solution. For that reason, a virtual machine sending a sign to the host is a good way, I think. Storage attachment. I run a container if I want to run a service. This approach has a bit difficult management of persistent volume. Now I use LVM on the host. I set up a logical volume with a label. And if I write the volume pool name and logical volume name to YAML, the script attaches it to the virtual machine. A label is useful. Ansible Playbook can mount the volume by the label. First, I design how volume to attach the container. Next, I create a logical volume and format with the label. Then, I load a playbook to mount it. I have a vision. One is the automation of this process. My solution can include this process in the script. I want a declarative volume. One is to use iSCSI. If I can do it, I can set up the persistent volume for Kubernetes easily, or to use a volume orchestration solution like Soda. I'd like to try to manage from the front end. Now I run the script to start and destroy the virtual machine, and I write YAML to configure machines. I have no complaints about this. However, if I manage it on LibreOffice Calc or web interface, I do this solution more easily and prevent mistakes. Especially web interface, I can manage my home VM system outside. When I do it, I should set up VPS or something to access my network. To cancel the creation, I want to set up this script to start when the host power on. If I develop it, to cancel creation is needed because I might shut down the host immediately. And what happens if I forget to destroy virtual machines when I shut down the host? I should treat these unexpected scenarios. Fortunately, I can destroy all virtual machines and I can recreate these, but persistent volumes might be broken. Automatically update premade MicroOS image. This solution copies the base MicroOS image for each virtual machine. This means update base MicroOS image can also update virtual machines. So I want to automatically download the system. And if I can, after downloading, run the test script. But I have only 12 cores. If I use Kubernetes, I don't have enough cores, although I might do a simple test. To rewrite by Python. I wrote these scripts by Bash. Bash is not a bad tool, but sometimes I want to use structures, and I want to use YAML more easily. I think Python is good to implement this solution. These are an overview of my home VM systems. Developing is continuing for more useful. Thank you. Listen to my session.